Okay, all right, everybody. Today we were going to be looking at adding fractions with different denominators. Now we have added fractions that have similar same denominators. But we're going to look at today, how do we add fractions that have different denominators? And when we talk about denominators, we know we're talking about the bottom number. Hold on, let me just get my computer. Okay, so let us do a quick review. Let us look at this one. We know how to do this. When we look at this fraction addition problem, we notice that this one has a denominator of 8 and this has a denominator of 8. So we're adding 2 8s plus 3 8s. Since they both have the same denominators, we know that that is very easy. What we're going to do is just write back the denominator of 8 and add the numerators. 2 plus 3 is 5. So we get an answer of 2 8 plus 3 8 is equal to 5 8. This is very easy and we have done quite a bit of them. So we have no problem here. But let us look at another example of adding fractions. In this example, we have a quarter plus a half. So when we look, the denominator is 4 and the denominator for a half is 2. Let me write it here so we can get a better look. A quarter plus a half. Now, because the denominators are not the same, we're not able to simply add the numerators to come up with the answer. So what we're going to have to do is to change one of these fractions into an equivalent fraction that has the same denominator as the other fraction in the problem. So let us look what we can do. We can change this fraction, a half, into an equivalent fraction that has a 4 as a denominator. Okay? And once we have changed this fraction here that is a half into a equivalent fraction with a 4 as a denominator, we can then match, it will be the same as this quarter, and then we would be able to simply add. All right, let me erase this so we can fix it up nice and neat. All right, so what is it that we're going to have to do to the half, to this fraction, to make it into a fraction with a denominator of 4? I know that I can multiply the 2 by 2 and I will get 4, and if I do that, I'll have to multiply the numerator as well. So a half is now going to become 1 times 2 is 2, and 2 times 2 is 4. So what we're saying is that this half now becomes 2/4. Remember, it is an equivalent fraction, so the value is the same. We're not changing the value of the fraction. Now, all we'll have to do is rewrite the problem. 1/4 plus, instead of using the half, now we're going to write equivalent fraction, which is 2/4. So we know a quarter plus 2/4, and we're simply able to, because the denominators are the same, we can just add the numerators, and the answer will be 3/4. All right? So that's nice and easy. Let us try another one. Let us look at this one. 1/8 plus 3/4. All right, let me write it. 1/8 plus 3/4. Now, when we look, we realize that the denominators are not the same, so we are going to have to get them to be the same so that we can add them. All right, we know that we can change, we can only use, when we're finding equivalent fractions, we can only use multiplication and division. We cannot use addition and subtraction. Now, I could really divide 8 by 2 to get 4, but because I cannot divide 1 by 2, I don't want to change this one. So I look over at 3/4 now. What can I do to the 4 to make it become an 8? I can multiply it by 2, and I would have to do the same thing to the numerator and multiply it by 2. So 3/4, the equivalent fraction now becomes 3 times 2 is 6, and 4 times 2 is 8. So I'm now going to rewrite this problem. So now we have 1/8 plus, instead of writing 3/4, I'm going to now write 6/8. And 1/8 plus 6/8 is equal to 7/8. Okay, so let us look at another problem. Let's scroll down a bit, hold on. All right, I want you to try this one for yourself. 1/3 plus 2/6. All right, so what I want you to do is pause the video now, take out your pen and paper in your math notebook, and I want you to try this one for yourself. Once you have finished it and come up with your answer, then you start the video again and see if you got it right. Okay, so now that you have done it, let us check what you have. All right, so we have 1/3 plus 2/6. All right, we are going to change the 1/3 into an equivalent fraction with a denominator of 6. What are we going to have to do? We're going to have to multiply the 3 by 2 and the 1 by 2. Then we're going to rewrite this problem. So 2 times 1 is 2, 3 times 2 is 6. So we are going to get 2/6 plus 2/6. And then because the denominators are the same, we can then add 2/6 plus 2/6. We add the numerators and we're going to get 4/6. But we cannot leave 4/6 this way. We cannot leave 4/6 this way. We have to reduce it or simplify it to the smallest that we can. We can divide 4 by 2 and we can divide 6 by 2 to get the smallest equivalent fraction. Are we simplifying? 4 divided by 2 is going to give us 2. 6 divided by 2 is going to give us 3. So the answer for this problem is 2/3. All right, so let's look at another problem. Let's look at a problem like this. This problem says 1/2 plus 2/3. So the first thing we realize is that the denominators are different. But we have a little problem here because there's really nothing I can multiply or divide 2 by to get 3. And there's nothing that I can multiply or divide 3 by to get 2. So I can't do the method that I was doing before. Hold on, let me write this here so we can take a better look at it. 1/2 plus 2/3. All right, so what we're going to have to do, we're going to have to think about what is the lowest common multiple of 2 and 3 that we have. And the lowest common multiple of 2 and 3 is 6. So we're going to change 1/2 into an equivalent fraction with 6 as the denominator. And we're going to change 2/3 into an equivalent fraction with 6 as the denominator. Okay? All right, to change 1/2 to get a equivalent fraction with a denominator of 6, I multiply by 3 and I multiply by 3. To get 2/3 to have a equivalent fraction with a denominator of 6, I multiply by 2 because 3 2s are 6, and I multiply by 2. So these two equivalent fractions are going to be 1 times 3 is 3, 2 times 3 is 6. The equivalent fraction here is 2 times 2, 2 2s are 4, and 3 times 2 is 6. Very good. So we now have the equivalent fractions. Now that we have 3/6 plus 4/6, we can simply add those together. 3 plus 4 is 7. 7/6. Now we know 7/6 is an improper fraction, so we cannot leave 7/6 the way it is. So we can say that 7/6 is the same as saying 6/6 plus 1/6. Remember we learned that in the class before? 6/6 plus 1/6 is going to be 1 plus 1/6. So the answer to our problem is 1 and 1/6. All right. If you're not sure what I'm doing right here, I have a video for it. So just go back and watch that video of changing improper fractions to mixed numbers and you will understand that. But that is in a whole other video. All right. So let's look at another similar problem. Let us go down and look. Here we have 1/3 plus a quarter. 1/3 plus a quarter. Again, the denominators are different, so I can't simply add the numerators across. And I can't think of anything. There's nothing that I can multiply or divide 3 by to make it into a 4. And there's nothing that I can multiply or divide 4 by to make it into a 3. So I have to find what is the least common multiple of 3 and 4 that we can use so that we would change this 1/3 into an equivalent fraction and this one into an equivalent fraction. And what we know is that the lowest common multiple of these two is 12. Right? So here we go. What do we do to 1/3 to make it into an equivalent fraction with 12 as the denominator? I have to multiply it by 4, and I multiply the numerator by 4. When over here with the fraction that's 1/4, what can I do to make this to be 12? I'll have to multiply it by 3. 4 times 3 will be 12, and I multiply it by 3. So what are the new equivalent fractions? 1 times 4 is 4. 3 times 4 is 12. And what is the new equivalent fraction here? 1 times 3 is 3. 4 times 3 is 12. So we now have rewritten the problem with equivalent fractions. And remember, so the value is the same. So now that we have the same denominators, 4 plus 3 is 7. And we have the answer would be 7/12. Okay? All right, are you getting it? I'm sure you're getting it. It's not too difficult. All right, so now I want you to try this one for yourself. So again, I want you to pause the video, open your books, and try it for yourself, and then come back and look and see if you got it right. Okay, now that you've done it, let us work through it together. So we have 1/6 plus 1/4. So we have to ask ourselves, what is the lowest common multiple of 6 and 4 that we can use? And the lowest common multiple of 6 and 4 is 12. You are correct, 12. What can we do to 1/6 to make the 6 become a denominator of 12? We can multiply that by 2 and multiply the 1 by 2. What can we do with the 4, the denominator of 4, so that it will become a 12? We multiply by 3 and we multiply by 3. All right, so let us rewrite these fractions into their equivalent fractions. 1 times 2 is 2. 6 times 2 is 12. So now we have 2 12s. Plus 1 times 3 is 3. 4 times 3 is 12. Now we can just simply add 2 12s plus 3 12s, and that is going to give us 5 12s. All right, so our answer is 5 12s. All right, I want to show you something because I think some of you may have done it in a different way. Let me rewrite the same problem here. Some of you may have said 6 times 4 is 24, so I want to use 24 as the denominator for the new equivalent fractions we're doing. If that's what you did, then you don't have to worry, you are okay. So let us go through that. 6 times 4, 1 times 4, and over here we would have 4 times 6 and 1 times 6. Let us see what happens. 1 times 4 is 4, 6 times 4 is 24. Plus 1 times 6 is 6, 4 times 6 is 24. All right? So you may be saying to yourself, boy, it's looking different. But let us go on. The denominators are now the same. So 6 plus 4 is 10 over 24. So you may say the two answers are different. But the two answers are not really different because these two fractions are equivalent. We know that we cannot leave 10 over 24 in that manner. We have to reduce it, and we can reduce it by dividing by 2, dividing by 2. And when we divide 10 by 2, we're going to get 5. And when we divide 24 by 2, we're going to get 12. So you notice the answer is the same. So it doesn't matter if you went this way or you went this way. If you use 24, you know you have an additional step, but the answer will be the same. Okay? All right? So that's how you do, that's how we add fractions with different denominators. I hope you have it. Just let me know if you're having any trouble. All right.